Hello everyone, welcome to Urban Subnet. Today we're going to talk about the Ethernet standards and the data link protocols that are used to help connect our networks together. Today's video topics are going to be the Ethernet links and the local area network LAN, otherwise known as the LAN, the 802.3 set of standards for Ethernet, the wired LAN and the wireless LAN, the Ethernet physical layer cables and equipment that are used to connect the cables to certain devices like switches and routers, the UTP copper wire cables and the fiberglass optical cables. The copper wire cables use electricity or electrical circuits to send data down the network, and the fiberglass optical cables use a laser light to send the data through the network cables or through the optical cable down to the next device. Ethernet uses the data link standards on all physical link technology. This means no matter what kind of cable you're using, whether it's a copper or a fiber, the data link standard is applied to that technology. The physical layer uses copper cables and fiber optic cables to link network nodes together. So the cables actually connect the devices together. Data link uses a header and a trailer in a packet to assist with the function of data transfer. So as you can see down here, we have a packet we shown here, and it has a header and it has a trailer. This does not change no matter what type of cable you're using or how fast the bandwidth on the cable may be. The format of the header and trailer do not change with the cable types or speed like I just mentioned, so that will not change whether you're using a 10 megabyte cable, 100 megabyte cable, or even a 10 gigabyte cable. The Ethernet frame type does not change. UDP, also known as unshielded twisted pair cable. The wires are made of copper and the wire pairs are twisted around each other to prevent electromagnetic interference or EMI interference. So this interference can come from a lot of sources: electricity, large machinery, factories, radio waves that are sent through the environment or the air, and they all can cause your cable to maybe lose some of its signal strength or lose some of the data or the signals within the cable. So they're twisted together. As you can see here, the wires are twisted around each other to prevent this EMI from causing problems on your network. The electrical circuit is created on a 2-wire pair for a 10 base T and a 100 base T network, so that's 10 megabytes or 100 megabytes. And a 4-wire pair is required for 1000 base T and higher. So your 10 megabyte and your 100 megabyte uses 2 of these pairs of cables, and your 1000 megabytes or 1 gigabit internet and higher use the 4-wire pair. So you got 4 wire pairs here, which are 8 wires altogether. The end of the cables are inserted into RJ45 connector that has 8 small inserts, so the tips of the copper wires can be exposed when inserted into the switch port or NIC card. So what you can see here is this is the RJ45 connector, and it has these little pins up here at the top. Once you insert your wires through, like you see here, you're gonna untwist the tip of the cable wires, and you're gonna insert them in here. They're gonna go, each one goes into one of these pins, as you can see. And then there's a crimping tool that is used to push down on these pins, and they'll puncture the tips of the wires, and that will expose the wires to the switch port. The wire pairs are color coded, as you can see here, so they can be easily identified and cables can be easily made. I've made many cables myself at work. Sometimes you may need to shorten the cable. You get a cable that is way too long, so if you got the RJ45 connectors and you got the crimping tool, you can cut the cable to the length that you need and just go ahead and make your cable and use it as needed in your network. Ethernet link is the physical connection between any two devices. So that is what our Ethernet link is. So when you take a cable and you connect switch 1 to switch 2, that is what you call the Ethernet link. The Ethernet switch is an access gateway for most user computers and servers. The switch has built-in ports that take the RJ45 connectors. So as you can see here in this switch, this is a 5-port switch, but it has the built-in ports, and this is a older model switch, but it has 100 megabytes and 10 megabyte capacity. And you can see the switch ports here. Now, you can find switches with, 24 ports, 48 ports, 96 ports. It all depends on what you need to get your network up and running and function. You can start with a 24 port switch, and sometimes as the need grows, you'll grow into a 96 port switch, or you could buy multiple switches, but the port density varies from switch model to switch model. Switches also can connect with the SFP, the small form factor connectors. SSPs are normally used on high-speed links of 1 gigabyte, 10 gigabytes or higher. So this is the SFP. As you can see, the copper pins are in here on this device here, and you stick your cabling to this end, and then you insert this device into the switch port. Now the ports will not look like these ports. They'll look more open space. You won't see these pins and everything in here. The SFP slides into the port and connects into the back of the switch to make the connection. And the Ethernet frame has the header and the trailer, which is very important as far as for transferring the data from the source to the destination. So let's take a closer look at the frame. First we have the preamble, which is up here at the top, and this is 7 bytes, the preamble, and it's just used for synchronization. And then you have the start of frame delimiter. Start frame delimiter signifies the next byte begins the destination MAC address of the frame. So now once you get here, it's going to signal to the equipment that the next byte will be the start of the destination MAC address. And then of course you have the destination MAC address, you have the source MAC address, and then you have the type, the length/type. The type defines a type of protocol that is used within the packet header. The type of protocol is listed inside the frame, so it tells you the type of protocol that's listed inside of the frame. And that protocol is most likely IPv4 or IPv6 because of the data link frame, or the data link services the network layer, which is the layer above data link. Then of course you have the data packet, which holds the information that's being sent across to the data, and it has a minimum length of 46 bytes. So if it's less than 46, let's say it's 40 bytes, then you get 6 bytes of what they call padding into this field of the frame to complete the frame. And then you have the frame check sequence, which provides the method of the receiving device to determine whether the frame has experienced any type of transmission errors. So that's what the frame check sequence will help prevent data from going across the network with errors or having to be reset, and or sometimes not even reaching the destination and being dropped. And at the end of my videos, I like to have a small quiz. I call it the Pop3 Quiz. So today we're going to talk about what we just discussed in our video. So our first question is, the physical layer cable, copper or fiber optic, use what protocol standard? So physical layer cables use what protocol standard? The answer to that is the data link standard, which we went over earlier. That's the standard that is used on all cables and all speeds of cables. Question number 2, What is the two most common protocols in the type field of the Ethernet frame? In the type field, we just discussed that the the most common protocols in the type field are IPv4 and IPv6, the addressing protocol. So you need an address to send, like this says destination source. You definitely need an address to send your data from one point to the next. Third question is, why are the copper wire pairs twisted around each other in the UTP cables? And that is because they need to prevent the EMI, electromagnetic interference, and it's also known as crosstalk between the wires. So you want to twist them together. They're twisted so you can cut down or prevent that EMI from causing problems on your network. I want to thank everyone for viewing this video, and if you enjoy our videos, please hit the like button and let us know. And you can also subscribe, because we're going to have much more videos to come. I want to thank you again, and have a good day.